There are two more sections left in chapter 7, and we are going to solve rational equations and another special type of rational equation. They're called proportion or ratios. Okay, so let's look at equation here. We have seen linear equations in Algebra 1. We have seen quadratic equations in chapter 6. Now there is another type of equation. There is some, one or maybe two, rational expressions within one equation. See, this is the typical one. What we see here, this is one equation because there is equal sign here. But in this equation, we don't see just polynomials. We see rational expressions. There are denominators in the equation. So this type of equation, we call them rational equations. To solve rational equations, see, do we have learned anything new? The answer is no. We have learned all the necessary techniques already. In other words, all the ingredients already. We just need to put them together to make another new meal. Okay, so recall to solve linear equation and quadratic equation. What do? So we never see any denominators. If we want to solve this equation, how about this? Let's get rid of all the denominators. When we look at this equation right here, this is one rational expression. I see the first denominator, that is x. When I check the right side, I see another denominator. It is also x. Okay, there are two denominators. They happen to be the same. How can I get rid of the denominators? So this is the recipe we are going to use. We have all the ingredients. Now we need a recipe. The recipe is multiply every term within the equation by the LCD of all denominators. So remember the recipe. Try to get rid of all denominators. How can we make this happen? Multiply everyone. This everyone means every term by the LCD. See, for this one, things turns to be very easy. Why? Because for the same denominators, their LCD, their least common denominator, is just themselves, still x. Okay, so having this in our mind or on your scrap paper, we do this. We are going to go back to the problem. The problem, we follow this step here. So first, we rewrite the equation, but split all the terms. So one term stay together, and then leave some space, write down another term. So the first term is x, I write here. And then plus 1 over x, leave some space between the terms, and equals 26 over x. So rewrite the equation. Then what do? We multiply the LCD, which is x. So everyone, so when I split the terms, everyone multiply by the LCD. The first one times x. The second term also times x. The third term on the right also times x. So multiply every term by the LCD. Now let's see what happens. Multiply them out, carry out the multiplication one by one from left to right. So the first one, x times x, turns into x squared, down. The second one, so look at, this is not new to us. We have done this before when we multiply a rational by a polynomial. This polynomial means it is staying on the top. So we just do the cancellation, divide. So x divided by x equals what? Equals 1. Those two cancel out. 1 times 1 is 1. I get x plus 1 equals, what do we have on the right? We have 26 divided by x times x. This x cancel out. What do we have? We have 26 here. What happens? After we multiply every term by the LCD, all the denominators are gone now. We have a new equation, and this new equation looks very familiar. What do we call it? Because it has a square term. This is a typical quadratic equation. Okay, to now recall what we did in chapter 6. to solve any quadratic equation, we want to make sure the right side of the equation turn to be 0. Then we apply zero product rule to solve the unknown. Okay, so what do I have here? I move everything to the left, and then I will have 0 on the right. So x squared plus 1 minus 26 equals 0. So take away 26 on both sides, or I say move this to the left side. Change the sign. 26 turn into negative 26 equals what? Equals 0. Okay. And then we'll just combine the left side. We'll have x squared minus 25 equals 0. To solve a quadratic equation, when we see 0 on the right side, what do we do on the left side? Factor it if it is possible. Okay, so we try to factor this. This is a typical 25 is 5 squared. Squares minus squares. What do we have? We have sum of the two bases because 25 is 5 squared. So factor this binomial. I have x plus 5 times x minus 5 equals 0. When the product equals 0, then we let each one be 0. So either the first factor be 0 or the second one be 0. So I was lazy. So I should have rewrite it. X plus 5 equals 0. What do we get? X equals negative 5. Or x minus 5 equals 0. What the x should be? X equals positive 5. And it turns out there were two solutions. Okay, so for all rational equations, we add one more step. So the difference between solving linear equation or solve quadratic equation, when we get answer, we know that's the answer. We don't need to worry about anything else. But for quadratic equation, we know there is something special about for the rational equation, there is something special, which means the denominator of the rational expression can never be 0. So for all rational equation, after we solve for the unknowns, and we add one more step, the check step. Check the answer. How do we check? We can plug this solution back to the original equation and then check, does the left side equal the right side or not? So this is a typical way to check the answer. For rational equations, if we are 100% sure we didn't make any mistake in the process to get the unknown right here, we just need to check, does any of the denominator which has unknown equal to 0 or not? So we do not need to worry about the entire equation, left side equal right side or not. We just check the denominators. This is a shortcut. As long as the solutions we got does not make any of the denominator which has unknown be 0, and then we know that's the right answer. But there is a pre-condition there. I said we didn't make any mistake in solving the unknown here. And so the safest way is to plug the unknown back to the equation and check the left side, check the right side, then see are they equivalent or not. But it involves some calculation because we have to maybe add, subtract some fraction number. A simplest way, if we are very confident, we know that we didn't make any mistake in getting those two solutions. We just need to check the denominators. Does any of the denominator turn into 0 when we plug this back? We quickly see the x are the two denominators. Neither of the two solutions will make the denominator be 0, and then we'll see both. So that's okay. So the solution, so x equals negative 5 or x equals 5. They are the solutions. There are the solutions. Safe. There are two solutions. They are the true solutions. Okay, so this is the one simple example. Now, just carry this same idea. No matter what kind of equation, rational equation do we have? We always follow this recipe. Look for the least common denominator of all denominators that we see in the equation. And then multiply every term by this LCD. So when we multiply every term, we write down the equation first. Separate all the terms. Leave us some room, some space to multiply the LCD. So that is only just make it easier for us to carry the multiplication. Somebody prefer to multiply LCD on the original equation given here, and then you have to squeeze things. So this one times x, this one times x, there is no times x, kind of squeeze things in. I prefer we have space, we have room on the paper. Rewrite the equation, split all the terms, and then everything will be so clear. Just move on step by step. This is one example. Now let me give you another example. Here, what do we have here? We have a rational equation because there were rational expressions in the equation. How many denominators are there? We quickly check there were 2. What are they? They happen to be equivalent, x minus 3, x minus 3. So we really don't have to put the things down on the paper. We know that if there is only 1 or 2 same denominators, their LCD will be still themselves. So I know the LCD, this is supposed in my mind. I really don't have to write this down. So LCD is still x minus 3. Then what do? I will rewrite the equation. So x over x minus 3. Okay, equals 3 over x minus 3. Leave some space here, minus 10. Same equation. Then I will multiply everyone by the LCD. So this one times the LCD. The LCD is a polynomial. Put them, all terms in one parenthesis. Second term times x minus 3 again. The third term, even though this one does not have a denominator, it has the same right with the other terms. Everyone else multiply the LCD. This one needs to multiply by the LCD as well. So this one times LCD. What we are going to do next? Carry out the multiplication. So this one times this one, those two cancel out. What is left? X is left. Equals, what do we have on the right side? So those two cancel out. This one on the top, this one on the bottom, they happen to be the same. They cancel each other. Okay, so those two cancel out. What do we have? 3 here. Then minus 10 times x minus 3. This turns into what? A linear equation. Why? Because after we remove the parentheses, there is no square term. So to solve a linear equation, we are going to do what? We are going to remove all the parentheses. And don't forget distributive law, negative 10 times x, negative 10x. Minus 10 times negative 3, negative turns into positive. So distributive law. This is the linear equation here. And what do? We have x terms on both sides. We are going to move them together. So x, this one stays on the left side, it stays the same. And this one is on the right. I want to move it to the left. When I move a term, I change the signs, like reorganize the equation. All x terms go to the left. So plus 10x equals 3 plus 30. Okay, I didn't do anything else. I just reorganize the terms. All numbers stay on the right. All x terms stay on the left. Then combine like terms. What do we have? We have 10x plus x equals 11x equals 33. How can we get x? Divided by 11 on both sides. I get x equals 33 divided by 11, x equals 3. Okay, so we are pretty happy now, right? So we found what x is. But don't forget, for all rational equations, we have to do one step. What the step? Check the answer. Check the answer. And so, Professor, we are pretty sure we didn't make anything wrong during the process. Do we still have to change the answer? The answer is yes. So why? Because let's see, if we plug the answer we got here back to the original equation, we just need to check the denominator. What happens? When x is 3, this denominator, x over x minus 3 turns into what? Turns into 3 over 3 minus 3. So plug x equals 3 back to the equation. 3 over 3 minus 3. 3 over 0. So when x equals 3, what happens? It makes the denominator be 0. And when the denominator be 0, that rational expression is undefined. The solution we got here will make the original equation to be undefined expression. So that means the solution we got here is a false solution. That is not the true solution. This is a false. If there's a false here, what does that mean? So we only got one solution. It turns out there's only one is a false solution. Then we'll make the conclusion here that original equation, this one does not have a solution. Not all equations have solutions. And this one we saw here happens to be one like this. This equation does not, or there is, you can also see no solutions. You can choose that, no solution. There is no solution to that rational equation. It looks like what we have done here. We follow the recipe, and this original equation turns into a linear equation. And we solve the linear equation, we got one solution here. We cannot stop here. Why? Because when we check the solution, it turns out this only solution we got so far will make the original rational expression be undefined. And that means what? That means there is no solution to the rational equation. That means the checking process is very, very important. Don't be fooled. When we got the answer here, we thought we got solution. It turns out that this is a false one. Okay, so I really want you to learn something from this example. Check the final solution. How? Just check the denominator. If the denominator is not 0, we'll take the solution. If the solution we got makes the denominator be 0, and we are going to throw this solution away. This is the false one. We cannot take it. Okay, this is another example. And let's see, maybe I'll give you one more here. Okay, so let's look at this one. When we see this equation, this is another typical rational equation here, because there are two rational expressions, and one on the left, one on the right. So let's see, follow the recipe we just got. There are two denominators, and what are they? The first one is x squared plus 3. The second one is 4x plus 3. Okay, so for the two denominators, what do we want to do? We want to look for their least common denominator. And recall what we did in section 7.3, the beginning of section 3, we learned to look for the LCD. We try to factor each denominator respectively. Okay, try to factor this first one, x squared plus 3. Can we factor it? The answer is no, no GCF. Binomial, this addition here, this one is not factorable. So then it will stay as x squared plus 3. So because it stayed together, we put this in a parenthesis. This turns into one factor. The second polynomial, the second denominator, 4x plus 3, no GCF. And this is not squares minus squares, so we cannot factor this either. This one turns into another factor. So those two factors, we can write down the LCD. We'll use every factor, the maximum times they appear in each factorization. So the first one, x squared plus 3, so LCD equals what? And I will have x squared plus 3. It appears once, 0 times here, once its maximum time. Then we move on. The other factor is 4x plus 3. And again, the maximum time it appears in both of those two are once. So once, we put them together. That will be our least common denominator. Okay, go back to the original equation. As we said here, we are going to split the term, rewrite the equation. So this first term, leave some space here, equals the second term, 4x plus 3, also have some space after 8. So rewrite the equation, split all the terms, then multiply every one by the LCD. So the first one is this, multiply the LCD, the product in those two, so x squared plus 3 times 4x plus 3. Okay, the space is not big enough. Okay, I should have left more room between the two terms. But it's okay, we can still see it. So the first one times LCD. The second one, do the same thing, also times LCD, x squared plus 3, 4x plus 3. And then what do we do? Carry out the multiplication. How? Do the cancellation. See, I see x squared plus 3 on the top. I see x squared plus 3 on the bottom. Those two cancel out. What is left? I have x times 4x plus 3 equals, and do the same thing on the right. Those two factors, they cancel each other. What is left? 4 times x squared plus 3. After I carry out the multiplication LCD, this step here, we found that all denominators now are gone. We have a regular equation. What equation do we have? It depends what is left. I did see the square term. It turns into a quadratic equation, but still we have to remove all the term, all the parentheses first. We apply the distributive law, x times 4x, 4x squared plus 3x equals 4 times x squared plus 12. So we do see what? We do see the quadratic term. So to solve a quadratic equation, what do? We are going to move all the term together, leave the other side to be 0. So 4x squared plus 3x minus 4x squared minus 12 equals 0. But after I do this, when we combine like terms, something happened. What happens? 4x squared minus 4x squared. Those two, they cancel out. This one minus 4. 4 minus 4 is 0. So what do we have now? We have 3x minus 12 only. It looks like it was a quadratic equation, but it turns out to be a linear equation now. To solve this linear equation, then we are going to move 12 to the right side again. 3x equals 12, x equals 4. Okay, I believe I didn't mess up all the calculation. Okay, and end up with x equals 4. What do I do next? I need to check my answer. Okay, does 4 make any of the denominator be 0? Quickly check when x equals 4, 4 squared plus 3 does not equal to 0. 4 times 4 plus 3 does not equal to 0 either. So now bomb is removed. There is no bomb left, and I will see. Check the denominators are all safe. X equals 4 is a true solution. So I will leave the 4 here. So 4 is the final solution. If you don't believe in this, you can still check the entire left side equals what? the right side equals, let's quickly check this. So plug 4 to the left side, it turns into 4 over 4 squared plus 3 equals 4 over 19. And the right side turns into 4 times 4 plus 3 equals is also 4 over 19. And those two, they're equivalent. Therefore, that is the true solution. So either way, I kind of took a shortcut. I only check the denominator. Or if you don't like this, you can always check the entire left side and right side. That will always be the right way to do that. All right. When I gave you this example here, I want you go back and look at what we just did. This is a special type of rational equation. How special it is? There are only two terms. There are only two rational expressions and one on each side. So this is one rational equation equals another rational equation. When we look for the LCD and multiply everyone by the LCD, do the cancellation, it turns out this one. So I want you to notice this new equation here. Let's look at what is the left side. X times 4x plus 3. When we go back to the original equation here, check those two terms. It happened to be the product of those two terms. So x times 4x plus 3. And equals what? Equals 4 times x squared plus 3. It happened to be the product of those two terms. Okay, so nice. Can we follow this and apply this method to all special rational equations like this? Whenever we see one rational equation equals another one, we skip. Okay, all those procedures. Look for the LCD, multiply the LCD. Can we simply just multiply those two terms or do the cross multiplication? The answer is yes. So we can actually skip those two steps here, jump to this step directly. Why? Because we do have a theory to back up this. And this is actually what is introduced in the next section, section 7.6, ratio and proportions. Those two concepts are not new to us. What's the ratio? The ratio means a quotient. When we have two numbers, two polynomials, one divided by the other one, the quotient is called a ratio. And what is proportion? The proportion means two equivalent ratios. That is a proportion. So when we have two ratios, they happen to be the same, then they're proportional. And this equivalent statement is called a proportion. What do we see here? The left side, that is a ratio. The right side is also a ratio. Those two ratios are the same. This is a proportion statement. For any proportion statement, the cross product are always the same. This is the theory about the rule. The mathematics are composed of all rules. There's the one rule about proportion. For any proportion, the cross product should be the same. So then what do we do now? We just multiply, cross multiply the terms. We have 20 times 12 equals what? Equals b times 48. Rewrite this. We got 240 equals 48 times b. When we cross multiply, what do we have? We got a linear equation. How can we get b? Divide by 48, divide by 48 on both sides. 48 cancel out. I have b alone on the right. And 240 divided by 48, it equals 5. Okay, what I got b equals 5. Now you might ask, Professor, do we have to check? Let's just look at the original equation. Does the unknown b appear in the denominator or not? There are two denominators. There is no b at all. So if there is no unknown in the denominator, we don't have to check because b has nothing to do with the denominator. It will never make them to be 0. So we have b equals 5. Final answer. It got to be a true solution. No check is needed. Why? Because the unknown does not show up in the denominators. This is so for what we see in section 7.6, ratio and proportion, we are still dealing with a special type of rational equations. Two ratios, two rational expressions, one on each side. So then we do not need to look for the LCD anymore. Just do the cross multiplication, solve the equation. And if it is needed, we still need to go check the answer. Okay, so what I have here, let me check. Let me look for some other. Okay, so let's look at a more complicated equation right here. Number 8. What do we have? We have step 1. We know it's a rational equation, but it is a special rational equation. That is a proportion. Just one term here, one term here. They're equivalent. So forget about the LCD. I can just multiply those two terms. It turns into x plus 3 times another x plus 3 equals those two. The cross multiply and x plus 5 times x plus 2. Okay, so what do we do next? We just remove the parentheses, carry out this multiplication on the left side. It turns into a binomial times a binomial. Apply the FOIL rule, FOIL. X times x, x squared. X times 3, 3x. And x plus 3, another 3x. Combine the like terms, turns into plus 6x. Okay, I did skip some step. If you can now do this, write down 3x plus o, I, 3x again, and then plus 9 equals, what do we have on the right? I have x squared, 5x plus 2x, that's 7x, and then plus 10. Remove the parentheses. We did see the square term. When we see the square term, it looks like it is going to be a quadratic equation, but it turns those two square terms, they have the same coefficient. So if you notice this, you'll see we subtract x squared on both sides, the square term is gone. What is left? We have a linear equation left. To solve a linear equation, move all x terms together. So I have 6x minus 7x equals 10 minus 9. Combine like terms, negative x equals 1. We're not done yet. Negative x equals 1. It tells us x equals negative 1. Divided by negative 1, we got this, x equals negative 1. Then quickly check. Do I need to check? Yes, because I do see the unknown appears in the denominator. So when I plug x equals negative 1 to both of the denominators, neither one is 0. So that means this is a true solution. There is no concerns at all. And x equals negative 1. See, for this special type of rational equation, we can simplify, skip the step of looking for LCD and then multiply LCD. We directly do the cross multiplication. And after we get the answer, check the denominator only. Okay, those are the techniques that we need to use to solve the rational equations. Okay, let me see. Do I need to give you one more examples? Okay, one more example. And because we haven't seen 3 denominators yet, number 10. And let's go for number 9. Number 9. This is 1. I don't like this. I like this one. This one turned to be a quadratic equation later. Okay, see, what do I have here? I have a rational equation. Can I do the cross multiply? The answer is no. Why? Because the left side, there were two terms. There were two rational expressions on one side. There is another one on the right. So only when we have one rational on the left, one rational on the right, we can cross multiply. For this one, this will be just a typical rational equation, and we cannot apply the proportion rule to it. Then what do? Follow the recipe, look for the LCD of all denominators. So there are three denominators, x, x squared, and 4. What is their LCD? The more practice we have, the quicker we can find the LCD. For the LCD will be just 4x squared. Neither one has 4. 4 appears once. And we have both x. For the same variable, we use the largest exponent. So 4x squared is LCD. Then go back here. What do? Split the terms. 25 over x minus 5 over x squared, space equals 45 over 4. Copy the equation. Split terms. And then multiply by the LCD. So this one times 4x squared, this one times 4x squared, and this one times 4x squared, 2. So all the three terms multiplied by the same LCD. So that will be this problem here. Then what do? Just simplify. Okay, I have x squared over x. So this x is canceled, and x squared turns into x. Simplify this multiplication. 25 times 4, 100. So 100 times x minus what? X squared, cancel out. I have 4 left. 4, 5, 20 equals. What do we have on the right? 4 cancel out. I have 45x squared. After I multiply the LCD, all the denominators are gone. I have a quadratic equation now. To solve the quadratic equation, what do? We move everything to the same side and leave 0 on the other side. So because the x squared term is on the right, so we move everything to the right. I have 0 left on the left side equals 45x squared minus 100x plus 20. If you don't like this, you can see for the equation, we can just swap the two sides, and we can rewrite as 45x squared minus 100x plus 20 equals 0. If you want, you can also see, Professor, can I move this term to the left? Yes, we can. But personally, I do not like a negative coefficient for x, for the x squared. I move them to the right. Then I just switch two sides to make sure the x squared term always have a positive coefficient. Nothing, is different. You can just follow your own way. You can choose either way. Then go back to this one. So to solve a quadratic equation, what do? We want to factor the left side. When we look at the left side, what do we see? A trinomial. And the leading coefficient is not 1. It means we have to look for 4 numbers. But before we do that, don't forget GCF. Do we see any common factors among the 3 terms? I noticed all of the numbers, they're multiple of 5. So what do I do now? So instead of just jumping to, like, for the 2 numbers, their product is 45. There were so many possibilities: 145, 315, and 59. Okay, and there are 3 combinations, and you get 20. So that will be too much to go through. So before I do that, I always follow the procedure. To factor anything, always check the GCF first. I notice They all have factor 5. So factor 5 out. What do we have left? 9x squared minus 20x plus 4. Okay, did I make any mistake? Okay. 20, yeah, should be okay. Equals 4. Plus 4 equals 0. Okay, and let me check. Double check. 4x squared, 4 left. Okay, 100x minus this 4 times 5, 20 equals 4x squared, 4 cross out. Move them together. I didn't make any mistake. Factor 5 out. 5 9, 45. 5 20x plus 4 equals 0. Okay, and then we are going to continue try to factor this. And I think I have to stop here. This one for now. So can we try to factor this? Let's try. Okay, 9, 3, 3, 9. Okay, let's try 3 times 3, that's 9. Okay, and 4, if I go to 1, 4, does not work to get 20. If I get 2, 2, does not work. So then I go try 9. 1 times 9. Okay, here we go. 1 times 9 is 9. 2 times 2, that's 4. When I cross multiply, I will get 18 and a 2. 18 and a 2 can give me a 20. Nice. Then because I have a negative 20 here, both of the two 2's should be negative. So double check here. Okay, double check here. 1 times 9 is 9. Negative 2, that's 4. When I cross multiply, 1 negative 2, that's negative 2. Negative 2, 9, that's negative 18. Put them together, that's negative 20. Okay, that is exactly what we are looking for. So we can factor this trinomial as the 5 stays here, x minus 2 times 9x minus 2. So 1 negative 2, 1x minus 2. 9 negative 2, 9x minus 2 equals 0. Beautiful. Now we have one equation. The left side is a product. So we will make each factor be 0. Can 5 be 0? Of course, 5 cannot be 0. What can be 0? Only x minus 2 be 0 equals 0. X minus 2 equals 0. Or 9x minus 2 be 0. Okay, how can we get the x? Plus 2 on both sides, x equals 2. Or 9x minus 2 equals 0. 9x equals 2, x equals 2 over 9. Then we will quickly check the denominators within the original equation. Neither one make the denominator be 0. So that means both of the two solutions are the true answers. So this equation has two solutions. X equals 2, x equals 2, 9. Final answer. Okay, if when we look at this equation here, it actually covers what we have learned from chapter 6 till chapter 7, end of chapter 7. But look for the LCD. Solve a quadratic equation. To solve quadratic, we have to know how to do the factoring. How can we factor this trinomial? Go look for the GCF first. For the leading coefficient is not 1. We need to look for the 4 numbers. That is not very, at the beginning, I thought I made some mistake. When I double check, there is no mistake, I go ahead. Try to look for the 4 numbers. Eventually, I did a lot of try. Eventually, I found those 4 numbers. Then I was able to factor this trinomial into 2 binomials. A lot of work behind. And then I make each factor be 0. After I got the 2 solutions, I checked and make sure both of them are the true solutions. So this equation here is not an easy job. It took me quite a while to finish it and get a solution. And this is a very comprehensive problem. If you know how to solve this one, that means you did very well in chapter 6 and in chapter 7. It covers the most important contents in both of the 2 chapters. A very comprehensive problem. Okay, so I hope this problem can give you some review and idea. Be patient. When we are solving a equation, we might have to do a lot of things, but the typical thing is whenever we have denominator in the equation, try to get rid of the denominators. How? Multiply by the LCD. For rational equation, don't forget to check the answer. Sometimes we might get some false solution. We have to double check the solution. After finish the check procedure, then the problem is solved. This is another example. Okay, and what I want to share with you more in chapter 7, end of chapter 7, sometimes we are not given the equations directly. What we are given? We are given some word problem. Okay, and for example, this is what I have here. Let me grab, there is a typical problem. This one. Here we go. Okay, there is one typical word problem. Okay. One pipe can fill a tank in 30 hours, and a second pipe can fill the same tank in 20 hours. So what do we get? So if each pipe work individually, and so we have a tank. If we draw a picture right here, there is an empty tank, and there is one pipe. Okay, goes in, so we have the water here. So if this pipe works only, we turn this on, open the valve, it will take this one 30 hours to fill up the tank. And there is another pipe. If this one works alone, it will take this one 20 hours to fill up the tank. Now we'll say, okay, can we turn both them on? How long will it take to fill the tank using both pipes? Okay, so water comes from here and here as well. Both of those two work together. And use our common sense. We know it's going to be faster to fill out the tank, right? To fill the tank. Why? Because more waters come into the tank with the same amount of time. And it will take shorter than the 20 hours or the 30 hours. But how much time can we get? Okay, a very, very practical problem in our daily life. How can we solve this one? To solve any word problem, step 1, like what we just did here, we figure out the information that we are given. And if we can draw a sketch. Oh, this sketch does not matter too much, but we get an idea. So we get when both of them work together, we are going to use shorter time. What exact time, we don't know. So after we read the equation and then read the problem, then assign a letter to the unknown, to the question. How long will it take to feed the tank? I don't know. How long means how many hours. Let's assume it's going to be X hours. Or you can choose another letter, T hours. It's totally up to you. So I would prefer use X. So I will use X hours. For both of the two pipes. So both of them work X hours. They will fill the tank. So this X is unknown here. So give one unknown to the question here. How long? X hours. Now we need to find one equation. So what the equation here? This is actually a rate problem. So then let's draw this. So if we have this pipe 1, this is pipe 2. Pipe 1, this is the time. To finish the job, how many hours does pipe 1 use? 30 hours. Pipe 2, it will use 20 hours. Okay, then the second one, we'll see the rate. So the rate means 1 hour. If pipe 1 fill the tank using 30 hours, then in 1 hour, how much of the tank is filled by the pipe? So it uses 30 hours to fill the tank. Then 1 hour, it will only fill 1/30 of the tank. If pipe 2 uses 20 hours to fill the tank, then 1 hour or per hour, it will fill up, okay, 1/20. So let me cross this. Okay, this is actually goes here. The rate is used, the time we are given is 1/20. This is a key step here, key step. Find the rate. What the rate? Per hour, 1 hour, how much work is done? Pipe 1 will fill up 1/30 of the tank. Pipe 2 work alone. It will fill out 1/20 of the tank. Now let's see how many hours they are going to work together. So the time here, both of them will fill out the X, will work X hours. So this is the total time they're going to work. They're both working X hours. Then let's see, after X hours, how much of the job is done by pipe 1. So 1 hour, it works as 1/30, and it works X hours. The total job done by pipe 1 will be rate times time. 1 hour, 1/30. It works X hours. So 1/30 times X. That will be the work done by pipe 1. How much is done by pipe 2? 1 hour, it works as 1/20. It works X hours. Then we'll get 1/20 over X. After we have this one here, we'll see after both of them work X hours, this one finishes this much of the tank, this one fills this much of the tank. What happens? The tank is full, and it means the sum of those two turns into a full tank. We make a full tank is 1. That's why we have 1 tank over 30. Rewrite this one, we get 1/30 times X plus 1/20 times X equals what? Equals 1. 1 means 1 full tank. The complete job is done. That is the equation we are going to use. So nobody gives us the equation. We figure out the information that we are given. We find out the rate done by each pipe, and we assign the unknown to the question X hours for each one of them. Then we find out the job done by each one of them. We put the two jobs together. We finish the entire job. What the entire job? Fill the entire tank. The entire job is, we let this be a number 1. And this is a typical rational equation. How do we solve the equation? Use what we learned before. There are 2 denominators. All right, so if you want, you can also write this as X over 30 plus X over 20, because 1 times X is X. 1 times X is X equals 1. This one looks even more familiar. To solve this equation, look for the LCD. LCD of 20 and 30 is what? It's 60. Okay, and this is not hard to find out, both of them. So 2 and 3 have LCD 6, and they both have a 10, 60. Then multiply everyone by 60. To save time, I'm not going to rewrite. So this one times 60, this one times 60, this one times 60 as well. Then simplify. 60 divided by 30. We have 2. Got 2x. 60 divided by 20. That's 3. Plus 3x equals 60 times 1, 60. Combine like terms. 5x equals 60. Or this x, 60 divided by 5, 12. 12 what? 12 hours. So when we turn on use both of the two pipes, we only need 12 hours. It makes sense. If you get a time longer than 20 or longer than 30, that does not make sense. Okay, so when we have the answer, just quickly check user common sense. It looks good. X, we didn't make any mistake. Non-denominator has the unknown, and we'll take this is the true answer. It will use 12 hours to fill up the entire tank, if both of the two things. And this is the one typical word problem. In this chapter, there are so many different types of word problem, and let's look at another one. Okay, so let's look at the other one. Okay. An apprentice takes 5 times as long to finish a job as it does a master plumber here. Okay, so there is apprentice and a master plumber, those two people. Working together, it takes them 4 hours to finish the job. How long would it take the apprentice work alone to finish the job? Okay, so this problem is a little bit similar to what we just did. And so this is a pretty challenging word problem. What do we have? We have 2 people. Okay, and the apprentice and the master, the 2 plumbers. Okay, so both of them, they're working. So now let's see, do we know if they work alone individually, how many hours do they use? The read, what do we have here? We find the apprentice takes 5 times as long as the master here. And so how long would it take the apprentice work alone to finish the job? So first we know the apprentice needs more time. It's 5 times the master. And for this one, I will assume here, to make things simpler, I will assume X is the hours taken by the master here. So the apprentice, so the master used X hours to finish the job. Then how many hours does the apprentice to use? 5 times as long as it takes the master here. So the master use X hours, the apprentice use 5X hours. So this is what we do so far. So I assign an unknown, not directly to the question here. Instead, I assign unknown, so X hours for the master. Then I know the apprentice use 5X. 5 times longer than that, 5X hours. Okay, so after we know this one, we are going to construct the table as we just did here. This is the apprentice, and this is the master here. We need to know their work rate. What the rate? 1 hour. The rate, so if the apprentice use 5X hours to finish the job, then 1 hour, the rate is what? The rate is 1 over 5X. To finish the entire job 1, it use 5X hours. So then 1 hour, it will finish this much, 1 over 5X. And the master uses X hours. The rate done by the master is 1 over X. So it use 2 hours, 1 hour, it will get 1/2. It's use 3 hours, 1 hour will be 1/3. If it's x hours, that will be 1/x. That's the rate. Then we'll see how many hours do they work together. So working together, it takes them 4 hours. The rate, the time to finish the entire job is what? It's 4 hours. Both of them work 4 hours. Now let's see if the rate for apprentice is this. He works 4 hours. How much work is done? Always multiply the time by the rate. So the work done by the apprentice is 4 times 1/5. The work done by the master is also time times the rate, 4 times 1/x. When those two persons, they work together, add the work done by them, they finish the entire job. That equals what? So the job done by the apprentice plus the job done by the master equals the entire job. Entire job is 1. Then we have the equation here. Of course, we do not like the format here. Rewrite it. We get 4 times 1/5 plus 4 times 1/x equals 1. Rewrite the equation horizontally. And this is the equation that we found by ourselves, which represent the original word problem, the practical problem. So nobody gives out the equation. We got the equation by ourselves first. Then what do we do next? Solve it. How do we solve it? Look for the LCD. 5x and x, the LCD is 5x. Then multiply everyone by 5x. This one times 5x, this one times 5x, and this one times 5x 2. Then carry the multiplication. Those two cancel out. We have 4 left. X cancel out. We have 4 times 5, 20, equals 1 times 5x, 5x. 24 equals 5x. Can we get what x is? X equals 24/5. Are we done? Not yet. This x represents the time for the master. Then for the apprentice, the problem asks for the apprentice here. So the apprentice needs what? Needs 5 times x. 24/5 times 5 equals 24 hours. And that will be the final answer. The question asks for how long would it take the apprentice work alone to finish job? He needs 24 hours. And the master only needs 24/5. That's 4.8 hours. If you use your calculator, this one equals 4.8 hours. And finish the problem. So this is still, so does not matter what information we are given. We just know there is one job can be done by each individual person. If we know the time needed for each individual one, we'll be able to find the rate. The rate is 1 over the time needed for one person. Then let's see if they work together, how much time. If the time is given, okay, write down the number. If the time is unknown, leave the x here. So no matter what, we get rate, we get time, multiply the rate by time, then we get the work done by each individual one. Put them together because they work together, they get the job done. The sum of those two jobs equals 1. Solve the equation, get the unknown. And again, before we make the conclusion, quickly check. Does the unknown make the denominator be 0? The answer is no, down. This is a very, very typical, we call this job problem. And on the practice sheet, or if you go try the text, the homework, you might see some other word problems, and just try to follow the same. I cannot give you all possible probably problem. They're all talking about different problem, the travel problem, and or maybe some number problem. Just be patient. Write down what we are given, assign one unknown to the question, then try to write down one equation. Okay, so whatever information is given, can we find something, some relation there? After we write down the equation, then solve it, and then check the answer. You will be done. This is the last two sections of chapter 7. And I have to admit that those two sections are still very challenging. So what we are going to do next week is the spring break week. So when you check your homework, you'll see the due date for chapter 7, the remaining part, is later than the spring break. After spring break, we'll go back to chapter 7 and have a review class again. We will get ready for our second midterm, 792. So pretty soon we'll have our second midterm. Be prepared. When you are working on the word problem, please feel free to reach out to me if you don't know how to write down the equation. It's not very easy. It's challenging. If you're stuck on one problem, it's very normal. So don't be